Okay, commercials. Is your favorite TV program often interrupted by advertising? CNBC presented statistics on the average number of programming minutes in a half-hour sitcom. The following data in minutes are representative of their findings. So we're given 20 data values in the table there. And it says assume the population is approximately normal. Provide a point estimate and a 95% confidence interval for the mean number of programming minutes during a half-hour television sitcom. So we are wanting a 95% confidence interval. And we're wanting this confidence interval to be estimating a population mean for the mean number of programming minutes during a half-hour television sitcom. And it looks like we've got 20 half-hour sitcoms in which we have drawn some data from. Okay, so we have to make a decision for the average as to what distribution we're going to use, and that is going to be based on the standard deviation that we have. And in this case, we are not given the population standard deviation or something that's very reliable estimating it. Instead, all we really have is our 20 data values. So it looks like to get that standard deviation for my confidence interval, I'm going to have to estimate it with a sample standard deviation. So that is going to lead me to use the t-distribution, and the formula for the confidence interval for that is x bar plus or minus t alpha over 2. And instead of sigma over the square root of n, it would be s over the square root of n, s indicating the sample standard deviation. So, getting my data set into the calculator or Excel, I can calculate the sample average. Turns out to be 22. The sample standard deviation is 1.119, and again our sample size is 20. We need the t-distribution value. It's a 95% confidence interval, so 0.05 is alpha, and I need a t-value for or a critical value for t.025. Now to find that, I need to go to the t-table and look in the column 0.025, and then the row is going to be equal to the degrees of freedom, which is the sample size subtract 1. So that would be 20 subtract 1 equal to 19. So in column 0.025 and in row 19, I find the t-value of 2.093. I can put all these values into my formula, 22 plus or minus 2.093, 1.119 divided by the square root of 20. And the first thing I'll look at is trying to get an estimate on my margin of error. And that is 0.5237. And that will give me my confidence interval, adding and subtracting that from 22. So 21.4 0.48 to 22.52. And I could say we are 95% confident that the real population average number of programming minutes is somewhere between 21.48 minutes and 22.52 minutes. In other words, the real population average mu is somewhere within 0.52 minutes of 22 minutes. Somewhere between 21.48 and 22.52. And 0.52 minutes is approximately 31 seconds. So our estimate of the population average, our estimate's 22 minutes, and we could be as much as about 30 seconds off from what the real overall population average is of all the half-hour his sitcoms, and we only took from 20 of them.